reactions are different. So if we were given a set of conditions, we'd be able to predict whether an E1 or an E2 reaction is going to happen. So let's draw an example of an E1 reaction first. And let's say we start with an example like tert-butyl chloride. Like here, we're going to start with a tertiary chloride. And our solvent here might be water, and we're going to have heat as well. And as we heat this reaction, we are going to have the loss of the leaving group. That is the key step and the rate determining step in the E1 reaction. We have formation of our leaving group, loss of our leaving group, and formation of the carbocation. So here's the Cl minus, and here is our carbocation. Actually, I'm going to draw it down here. I'm going to draw it up here. Carbocation. Of course, in this case, we've got a tertiary carbocation, which is considerably more stable than secondary or primary carbocation. And that is where our molecule of water can come in and takes a proton away from what we call the beta carbon here adjacent to the carbocation. And that's going to give us our new alkene right here, as well as in this case a molecule of OH3 plus Cl minus. So those are the products of that reaction. So 2 steps: loss of leaving group and then deprotonation. So then let's look at the E2 reaction and how this reaction is different. And we can even start with the same substrate. We can start with tert-butyl chloride as well, and let's just show the different set of conditions. Actually, before I go back in the E2, just remember that the E1, we're also, under these conditions, going to have a considerable amount of SN1 as well. The E1 is going to be a minor product in this reaction. So this is actually going to be pretty minor, and the SN1 is going to be major. Okay, so sorry, let's go back to talking about the E2 reaction. So say we're using a strong base such as NaOH. So we might have Na plus OH minus. So what's happening in the E2 reaction, we can also show the solvent for strong bases is usually the conjugate acid. So in the case of NaOH, our solvent will usually be water, and sure, we can add heat to this as well. And in the key step of this reaction, we are going to be losing our leaving group. So actually I'm going to draw the chloride over here this time. And we can have our hydrogens on the beta carbon and our OH minus. And we can show the lone pair from the OH taking away the proton. At the same time, we're forming a double bond and we're losing our leaving group at the same time. So we're going to lose our chloride as a leaving group. And that is going to give us our product here. This is the E2 product. And we will also generate water because we're forming a hydrogen to oxygen bond. And we're also going to form Cl minus, which will be accompanied by Na plus as a spectator ion because we used sodium hydroxide. So in the E2 reaction, it's all in one step, and you can see in the E1 it's in 2 steps. And this, of course, is our major product. There's no other byproduct of this E2 reaction here. Okay, so now that we walked through the E1 and the E2 mechanisms, let's make a little sheet which compares the different features of the E1 and E2 reaction. So in terms of the rate law of the E1 and the E2, we said that the rate law of the E1 was that the E1 was unimolecular. It was unimolecular. So the slow step was formation of carbocation. So and by contrast, the E2 was bimolecular. So we had both the base and our substrate present in the key step of the E2 reaction. And the key step was deprotonation of the substrate by the base. Okay, so formation of carbocation versus deprotonation of substrate by the base. Now the big barrier, the sort of the thing that limits this reaction from occurring in the case of the E1 is essentially how stable is the carbocation. So carbocation stability really is, so tertiary is going to be faster than secondary, which is going to be much faster than primary. And that's really what prevents or assists the E1 reaction from occurring, is how stable is that carbocation that we're forming. Now the E2 is not really a big barrier except for stereochemistry. So actually let me adjust this a little bit here. But the stereochemistry matters. It has to be anti-periplanar. Hydrogen and the leaving group. Okay, so you don't actually, you can have still an elimination reaction occur on tertiary, secondary, or even in some cases primary halides, but the key thing is going to be the stereochemistry to make sure that that can actually occur. And the last thing to talk about, contrasting the E1 and the E2, is the identity of the base. And in the E1, it's usually a weak base, usually solvent. So for example, water, or your alcohol if you're using alcohol or a solvent, or ethanol if you're using that as a solvent. So usually a weak base. And for the E2, we're going to be using a strong base. Strong base, so for example, you'll notice they have charges on them. So sodium hydroxide, or sodium ethoxide, so the conjugate base of ethanol, or sodium methoxide. So these are all examples of strong bases that we'll use in the E2 reaction. And maybe I should have had another slide here for the solvent in the E2 and E1. Usually we're going to be using, so for both, we usually use protic solvents. Not always, but usually protic solvents. They help, in the case of the E1, they help the leaving group leave because they hydrogen bond to the leaving group. And in the case of the E2, usually protic solvents because they are the solvent for our strong base. So those are that's another factor to think about when you're comparing the E1 and the E2 reactions. So maybe we'll just go back, have a look. So here we have an E1. It's occurring in two steps. We have a weak base, which is water, and we have two steps, carbocation formation and then formation of the alkene. Here we have our strong base. It's occurring in one step, this elimination reaction. And again, our solvent is water, which is a polar protic solvent. So all things considered, so the last question is really, when do you know when something, let's say we had E1 versus E2. Notice here that the only difference is that we have a strong base present and we have our solvent present as well. So the really rule of thumb is, if strong base is present, and assuming the stereochemistry works out, E2 will dominate over E1.